Well, hello, calculus students, geometers and seekers of truth. Welcome to this video where we are going to talk about some review problems here regarding polygons and similarity and perimeters. So we're looking for the perimeter of polygon B given that the two polygon A and B are similar. So the ratio of corresponding sides of A to B, this is known as the scale, or the scale factor is 5 to 6. So that means that A is the smaller of the polygon and B is the larger, because we're saying A to B is 5 to 6. So we can say then that the perimeter of A over the perimeter of B is equal to 5 over 6. Okay? And then we can make our substitutions. So we know that the perimeter of A is 15 meters. The perimeter of B is the thing that we're looking for, or x, and that's equal to 5 over 6. 5 over 6. So multiply both sides by x, multiply both sides by 6, and we will get that 90 is equal to 5x. Many of you know this as cross multiply. And then 90 divided by 5 is 18 meters, and that is equal to x. So again, we're just using the fact that the similarity between two polygons tell us something about the scale factors of their perimeters. Let's go on and look at a couple more examples. So in our second example here, we have the side lengths from A to B is 3.5 to 2. So in this case, we would say that A is larger. A is larger. All right, and we can set it up the same way. The perimeter of A over the perimeter of B is equal to, let me get a pen that works here, 3.5 over 2. So let's work this out. We know that the perimeter of A is 25 feet. So we have 25 over x, that's the perimeter of B that we're looking for, is equal to 3.5 over 2. Now me, just as a matter of algebra, I find it a little bit easier if we convert this fraction with a decimal in it. So I'm going to say 25 over x is equal to, and I'm going to multiply the top and bottom here by 2, 7 over 4. So 7 over 4 is the same as 3.5 over 2. We're going to multiply both sides by 4 and both sides by x, and we get that 100 is equal to 7x. Divide both sides by 7, and we get 100 over 7 is equal to x. And so 100 over 7 is about 13.28. In the next and last example that we're going to do in this video, we are going to look at number 3. So this time we're comparing the lengths and the legs of right triangles. So the legs of a right triangle FGH are 15 and 17. So let's draw this picture here. And these are the legs, right? So not the hypotenuse, but the legs are 15 and 17. And this is FGH, and it doesn't quite matter what we label these points as long as we label them F, G, and H. And then we know that the shortest side of JKL, so JKL is going to be a little bit smaller than FGH, so this is going to be 3.8. How long is the hypotenuse? How long is the hypotenuse of this one? So the first thing that I'm going to do is figure out the hypotenuse of GHF. So I'm going to figure out this length right here. I'm going to call that y. Okay. So I know that y squared is equal to 15 squared plus 17 squared. All right. So from this, we're going to get that y squared is going to be equal to 514. and y is going to be equal to the square root of 514, which is about 22.672. Okay, so that's this length here, 22.672. And now we have a couple choices as to how we're going to finish solving this problem. We could use similar proportions and try to figure out this other length and then try to figure out the hypotenuse using the Pythagorean theorem. But a simpler way perhaps is for us to just use proportions directly. So let's call this length here x. That's the hypotenuse of the other triangle that we're looking for. So we get that x over 22.672 is equal to 3.8 over 15. All right, now we're going to set that up, and then we're going to multiply both sides by 22.672. And so this looks a little bit complicated, but all we have to do is let the calculator do the work here, and we'll get our answer. And so our final answer is x is approximately equal to 5.743. Let's see, the units here are in meters. All right, so there you have it. 3 examples that deal with various lengths and perimeters of similar objects. In some cases, triangles. In other cases, just similar polygons. Right? The key is to use the scale factor and use that to kind of help us work through the problem. As always, thank you for watching. Ask for help if you need it, and have a wonderful day.